Hi everyone, my name is Yun Huang, and my project is about cloud generation. Here's the outline of my presentation. Let's start from the introduction. The main purpose of this project is generating volume clouds from 3D textures. The texture is pre-generated, and I use it as a 4D texture, which means the fourth dimension is time. Parameters for texture generating are hard-coded, so they won't be considered as the input, while other input parameters, which on the GUI window, could be changed on the fly. Those input parameters are including height of the camera, scale, and position of the cloud. The cloud is rendered by remarching inside the box, so it's actually changed the scale and the position of the box. There are also parameters for controlling the basic shape and details for the cloud. Two color picker for the light color and cloud color, and a recessing button to set the preferred parameters. And output is the cloud rendering on the screen, which calculates in the frame shader and runs into a cloud. For the solution part, here are three main algorithms works for the final result. Generate the noise, sample the cloud density from the noise and rendering. The noise texture are generated on CPU and saved as two raw files. I generated both poly noise and wordy noise. To render the result, I drop a cloud which has the same size of the screen, and in the frame shader, calculate the result of the cloud by remarching. In each point of remarching, I sample and mix the value from the noise textures using freckle Brownian motion. I generated two 3D textures, one works for the shape and other works for the details. I store those boiling and inverse volley noise in 4 channels of the shape textures. The detail texture is mostly the same, but much smaller, and only has 3 volley noise in different frequencies stored in the RGB channel. But the detail texture are generated as a repeating seamlessly texture, which means we could scale it in a pretty large range. Since the resolution of the cloud are mostly decided by the sampling of the detail, we could use this feature to fully scale the detail textures to pick the best value. For the cloud rendering part, I cast the ray from the camera and make them intersect with the box which contains the cloud, and find the entry and exit point, and do the marching between them. After decide the basic shapes of the cloud, details will be added by the edge of it, and the final density of this point will be multiplied by the light and cloud color and accumulate along the ray. According to Bayer law, the further we get into the cloud, this contribution of the density will be accumulated. For each step of the marching, I remap the position from the world position to local position. The scale of the remap could be controlled by these sliders, cloud shape scale and cloud detail scales. Here are some examples of how this value influences the result. More will show in the left demo. And the light of the cloud will be calculated by casting ray from current marching point based on the light direction. The algorithm I used in sampling the density of the cloud is called freckle Brownian motions. Combine the noise value from different channels as the final result for current matching point. The weight of each channel will be controlled by the GUI window, both for shape and detail. Here's an example of the shape texture shows how freckle Brownian motion combine everything together. As for the data structures, the most important data structure I used in this project is in frame shader for remarching. I use ray head to store the entry and exit point along the ray and calculate the volume based on them. As for the communication between the input and output, let's take a look at the GUI window. Those parameters are all works for the on-the-fly result, but not the noise-generated part. Those parameters are all set as uniform variables and assigned to the shader. We'll see directly how that works in the live demo. Here comes the live demo. As you can see, the cloud is just moving slowly by time. That's because I sampled the 3D textures, which is large enough, and I sampled and used it as the 4D textures. And the first dimension is time, as I said. So let's just try those parameters, and here's what I call the GUI window. And for the first one, the camera height, it just simply change the height of the camera. And for the box scales, as I said before, the cloud is set inside the box. So if you change the scale or the position of the box, it's actually change the scale and position of the cloud. So if you get it bigger, you can just fill all the screen of it, and it will try for another type of the render result, but let's try it later. So, and there's also the parameters control the sync of the cloud, and if you can get it to lower sync, it will be really transparent, and you get it to bigger, it will be really thick cloud. And for the box positions, oh, by the way, if you just mess everything up, you can just simply click the reset things and to get the preference parameters value. So for the position, I'll just try it. So you can just move it closer to me, and you can just dig into the volume. That's which my favorite part. And just look through the volume. Maybe I'll try to make it kind of fly through later. I mean, control the camera. And also reset and get the basic shape of the cloud. Yeah, and this two pair of the cloud shape FBM value and also the cloud detail FBM value, those are two most important values for this project. And if you, so just try it one by one. This comes from the FBM, aka the frequent body motions, and if you just get every value to the really lower side, it will be disappeared. And if you get one, okay, then we see the first channel of the texture is the purling value. And so let's try another. Here comes the low frequency volley value, and now it's the higher median frequency, and here's the highest frequency. Reset. And if you really want to get blobby scales, you can maybe try this channel and get lower burning values. That's just mostly how it works. And for the cloud shape scales, you can just scale the cloud to large scales and to something smaller. So let's just get the clouds smaller and to move some space for the details, since you might see the details at the edge of the clouds. So let's just try the details parameters. Simply, it just also works from the frequent body motions, and if you set it to the high value, it will get more details on the clouds. But it also has a problem is that if you set really high, and you'll get this bug, so do not set all of them to very high. But actually, if you just set one channel to really high value, that's okay. And also, let's try the detail scale. If you use the detail scale, you can clearly think that the scale will be larger details, or less details, should I say, and there will be the more details. So that's actually what I figured out to use the repeating seamlessly textures. And let's try the color pickers. And therefore the light color, and we'll get it to maybe add more colors to it and change the colors. And get a cloud, maybe to another different textures. Oh, this look ugly. And we'll get to maybe just pink color. Or get some color really dark. It will still works. And the light color is combined to the sky colors. Reset everything, and if you just mess up when you play with my program, you can just try the reset buttons. And also at last of the demo, let's try the wheel for the upper wheel. So let's just guide the camera to the lower way and get the position here and scale it to the fill all the screen. Try some other parameters and some scales. Maybe just use the default scales, but no, I can't decide now. So you can just play around. Oh, so that's all for the demo. And here's the conclusions. The achievement of this project is I implement a volume cloud generator. It has multiple parameters to control the result, and it could render in real time. Well, the problems including the cloud generator could just generate this flat type cloud. Could it be more types of it? And could I achieve a higher resolutions? More research are needed. And I would like to try more ways to sample the texture and even try more noise type. The Boolean noise and whirling noise are used most often in cloud generations, but I wonder if there are other noise could work for more types of clouds. And this all for the presentation. Thank you for watching.